Hello, thank you. Nothing I'm going to say is going to be particularly new to anybody. What I'm going to do, rather, is for whatever reason, and also it's nothing that my colleague Yves Marignac doesn't know better and in greater detail than I. And some of this is based on his and others' work. What this is essentially is the presentation that I gave to the French Parliamentary Committee on Decommissioning. And as we've learned earlier, they've recently published their findings. The last day of their inquiry, they saw two people. They saw me and they saw the head of decommissioning EDF. So, and also what I've tried to do, but I won't sort of rehearse it all, is because of, I don't really know why we're speaking in English, but we seem to be, but I try to be bilingual, rather unlike many other UK people. So these are EU decommissioning cost estimates, as our colleague has just pointed out. These are the estimated decommissioning expenses, that's billion per gigawatt by generating capacity. And you see a certain kind of movement here that seems to be relatively apparent. One of the things that is striking is both the UK's position and France's position. Now, the UK position is perhaps skewed by the existential problem that we have at Sellafield, but also the French position does seem to be kind of interesting. These are EU's figures. On the other hand, Germany, the strongest European state in the Union, the most scientifically adept, the most economic strong power, has set aside about 38 billion euros to decommission 17 nuclear reactors. UK, NDA estimate, clean-up costs of 17 nuclear sites, including Sellafield, 109 to 250 billion over the next 120 years. Now, of that, at the moment, about 80 billion is Sellafield. And we all know what's gone on in Sellafield. It's interesting to note that about 2005 or so, the estimate, the total cost of that is about 50 billion. So for some odd reason, in the last 10 years, it's shot up, it's doubled in the last... France has set aside 23 billion for 58 reactors. 23 billion for 58 reactors. Now, the reason why France has done this, is well, we'll come to that later. Now, the Commission, according to the Commission, France's estimates it'll cost 300 million per gigawatt of generating capacity to decommission a nuclear reactor. As we can see, this is far below Germany's assumption at 1.4 billion per gigawatt and the UK of 2.7 billion per gigawatt. So how can EDF decommission at such a low cost? What's the deal? Well, EDF say it's because of standardization of some of the reactors and because there are multiple reactors located on single sites. And this was a point of discussion that we had. This was the key, one of the key points of discussions that we've had. And we've already heard from a set of experts that there's no such thing as a standard nuclear reactor or how to decommission a standard nuclear reactor. So there are certain kinds of problems with this kind of argument. Who will pay? And the examples I'm drawing on are UK because I'm English and France. In UK, the UK government will pay most of the costs for nuclear decommissioning and existing waste. Now, in terms of future waste, that's another bag of tricks. We can talk about that later, and I'll be happy to answer questions about that later. But that's the current state of affairs. Of course, in the early 2000s, what happened to the UK is probably what will happen to most other places, is that the industry ran out of money. It didn't have enough money. So at a stroke of a pen, all of the industry waste liability decommissioning burdens became national UK government, the people's waste decommissioning and liability burdens. In France, for the moment, EDF must pay for it all. So the question is, has EDF set aside enough money to cover the huge cost of dismantling and cleaning up its existing nuclear power stations? Well, here's the EDF's nuclear funding challenge. 23 billion it's set aside to cover the dismantling of 58 French reactors, and the estimated costs of decommissioning and waste storage is 54 billion. Now remember that we've seen earlier that 54 billion seems to be, compared to other states, a relatively low figure. But yet there's a discrepancy between current funds and EDF's own acknowledged understanding of what it needs to pay. So how will EDF close this huge funding gap? Well, EDF says that the gap between this 23 billion to cover decommissioning and waste storage, and we've heard about the problems associated with disposal, and the estimated 54 billion costs will be closed through the appreciating value of its equities, bonds, and investments. In other words, as Mark Johnson talked about earlier, this notion of discounting. The notion that you can set aside some money now and that in 10, 20, 30, 40, 50, 100, 200, 1,000 years' time, it'll be worth a lot more. Unfortunately, as we know, the markets tend to go up and down. Now, why has EDF underestimated the cost of decommissioning and waste storage? Well, even EDF's 23 billion provision for decommissioning and waste is a large sum of money for a company that has huge borrowings and enormous debt. So here you're beginning to see the interaction between sort of politics, economics, and the notional idea about decommissioning and waste, how these things interact. We're not simply talking about the scientific or even the economic. We're talking about the complex interplay between science and society here. What's EDF's debt? Well, it's relatively large. What is it? It's about 37 billion current estimates. And of course, any significant change in the cost of decommissioning would have an immediate impact on EDF's credit rating. So, in this sense, what I'm trying to elucidate is that we're not necessarily talking about facts here, because facts are constructed. As the French say, c'est un fait accompli. Facts are made, facts are constructed. And certain facts about decommissioning, certain facts about waste are constructed for certain kinds of reasons. And here's one particular example of that. Largely because of EDF's, in this case, I'm pointing to EDF because it's a glaring example. There are other financial problems of bailing out Areva. We know about Le Creuset, Flamanville and the EPR extending the life of France's nuclear reactors at a huge cost, and the estimated cost of storing radioactivity is steadily rising. And there's been discussions about this idea of storage or disposal, this notion of a final solution for nuclear. And it's something that I said to the Commission that seemed to sort of bring home this notion of, if not me now, then who? If not now, then when? This notion of people trying to take on problems that they're not fully equipped to take on. This problem about nuclear waste, nuclear disposal, it's an overweening problem that no one really, in truth, has an answer to. But it's much easier to cling on to an idea that we do know what we're doing, that we do have an answer, that deep disposal is something that we can perform, where at the moment all the evidence is to the contrary. And certainly in terms of principles of proof, there is no functioning deep disposal anywhere. The key about disposal is this: if you can say that you can dispose of something, then you can create more of the same. It's called the Flowers Dilemma in the UK. Now, in terms of France's own problem, ASN, the French regulators, say that radioactive waste disposal is a much bigger problem than dismantling simple decommissioning, which is what we're talking about. We're talking about simple decommissioning here. We're not talking about storage of spent nuclear fuel. Nuclear waste, high and medium level waste, including spent fuel, must be dismantled and moved to a new facility which is not built yet. Now, the problem in France is that the cost of this so-called answer to the problem at SIGEA UNDRA, which is the formal body that does it, has recently increased the estimate for CIGEO planned national nuclear waste repository to 25 billion. Now, 25 billion, it's actually quite a very, very, very low cost estimate. But this is just an estimate, and this is what we're talking about. We're talking about estimates here, estimates about decommissioning, estimates about waste. We're not actually talking about the reality. We're talking about certain kinds of estimates based on certain kinds of models. When I asked earlier our colleague, I'm sorry, have to pick on our Swedish colleague again. When I talked earlier about, can I please have a scientifically validated? If you don't know what you're doing, what you do scientifically is that you try to bound your uncertainties by confidence intervals. This is a statistical mathematical measure by which you try to lessen the amount of uncertainty in your models and in your statistics. So it would be nice to have confidence intervals, which is sort of a mathematical way of saying, let me know how much you don't know about what we're talking about. And indeed, what we're talking about, the more you do that, the more you realize that the confidence intervals expand and expand and expand and expand. And they expand further over time. Further over time. 10 years ago, the UK debt for waste and decommissioning was 50 billion. Now it's 110 billion. What has happened in the last 10 years? What has happened in the last 10 years? So, although this 25 billion, which is a meager amount actually, is 5 billion more than EDF anticipated, it still seems a gross underestimation, and the costs are likely to rise considerably. And of course, EDF must pay for CIGEO. And let's not even think about La Hague, which is second to Sellafield in terms of what's going on. One understands actually that spent fuel stores are reaching their current cooling capacity, which is something relatively serious. And ASN have identified problems with some transport flasks, which has substantially slowed spent fuel transport to La Hague. Now, what this means is you've got a build-up of spent fuel at nuclear sites across France, with the associated problems of cooling the spent fuel at nuclear sites during the dry summer periods, because we know that the French are switching off a number of their plants at summer because they can't get the cooling. Now, this will impact on the spent fuel stores. So, conclusion, and this is the conclusion that I gave to the committee, I'm just sharing with you as an example of what's happened. Soon EDF will have to start the biggest and costliest nuclear decommissioning and radioactive waste management program on Earth. It seems very likely that EDF may have seriously underestimated the real challenges and costs, and this will have serious consequences for the French state who underwrite EDF. Now, if this is true to France, this is also true for other states as well too, even given the line that we've seen here. Because remember that Sellafield alone accounts for about 90 billion of UK's 110 billion. So simply keep in mind, when you're talking about cost estimates for decommissioning, when you're talking about cost estimates for waste, it's what the English call a piece of string. In other words, literally, in strict scientific terms, it could be anything. Thanks.